Hey everybody, and welcome back to another video in this series. So in today's video we will be looking at the GenerateTrajectory node that the Game Animation Sample Project has within their Anim Blueprint. So it was funny because I knew eventually I was going to have to get into this node or this function node just because there was a tutorial. It's like a written tutorial series by Epic Games that goes by your first 60 minutes in motion matching, and I wanted to do a tutorial series on that because it is a very basic, it's a very nice basic way of going through motion matching using the Lyra starter project animations and whatnot, and creating basic motion matching stuff to try to get you used to it. And part of the thing that's within that is the GenerateTrajectory function node. So I did find that kind of funny that I'm going to be going over it in a more complex way in this video, so but whatever. So let's go ahead and get started in this. So what we're going to do is, where we last left off, we had made our set references function within our initialize animation, and then within our event tick within our animation blueprint we created our update essential values, and then in our anim graph we did create the offset root bone, which also, by the way, I did get a little bit more information in regards to it, where I was right in the way I was explaining it. I was just kind of like thinking weirdly about it. So the offset root bone does adjust the move, or allows the game animation sample project to adjust the movement and rotation of the root bone of the character's skeleton mesh during animation updates. So it can also be handy for refining the way a character's root bone behaves in order to match the overall movement and collisions, right? So there is a lot more to go into. So what I will probably do is, in another video, either next video or probably in a future video, I'll go over specifically what each of these are doing, or just when we end up getting to the functions for this. So I'll probably do that as the next video, as kind of like an offset video, just to kind of explain what this is doing. But going back into it with the event graph, so what we're going to do now is we are going to create the GenerateTrajectory. So in the event graph, we are going to create a function, or actually, yeah, we'll just do it in here under functions, and we're going to call it GenerateTrajectory, just like that. And now we are going to get started. And with this one, there's not a lot to go over, but there's a lot to explain, or at least lengthy explanations as to what's going on at each part. And I do have a thick amount of comment notes to help me kind of understand, and also to allow me to explain what's going on at each part. So within the GenerateTrajectory node, what we are going to do first is we are going to grab the pose search GenerateTrajectory node. So this is pretty much how it looks, and as you can see in the description, it's used to generate a prediction trajectory based on the current character intent. So when kind of doing some research about this node in particular, obviously one of the things that comes up is we do get this from the pose search plugin that we did install yesterday as part of the update essential values. So with this node, like I said, it is used to generate trajectory predictions using data from our animation instance that we are going to be hooking up in here. So it helps and anticipate the character's future movement based on whatever our current anim state is. So to kind of show you how it goes, the first thing we are going to do is we have to get our anim instance. So you'll see in here that there's, when we go into here, that there's nothing, but you'll notice in GASP how they have a weird what they call a pre-event graph node. And what I found out with that, because I had no idea how to grab this until basically kind of earlier today before making this video, was that in order to get that node and call that function, you first have to look for a property access node, which is right under here under variables, property access. So as you can see, when we grab the node, and we hover over it, we use it to access properties according to property paths, meaning whatever we set in here, it paths to that and get whatever properties we bind in it. So in order to get the getAnim instance that they have, we need to go into the bind, and we need to go to this getOwning component, because you'll notice that in the actual property access within the game animation sample is that it has the getOwning component dot getAnim instance. So what that dot essentially is a sub event or sub function underneath the getOwning component function. So we have to go here to getOwning component first, and then we want to grab this anim instance, not this one, because then we have more subsets. We're not trying to get more, sub functions within the getAnim instance. We want the overall anim instance, so that way it grabs all of these, right? So where did it go? It would be, right here. So once we have that, we can then hook it into this anim instance, because now we are referencing our animation blueprint instance and accessing the properties involved in it. So just to kind of go over it according, to what I have set in my comment notes, is that this accesses the owning components animation instance, which is necessary for gathering information about the character's animations. So what I'm going to go ahead and do is let me comment my comment in here for y'all to jot down, and then we can move on to the next part. So now this one is pretty interesting, the in trajectory data. So what I'm going to do first is before I explain exactly what's going on, let me go ahead and set it up according to how they have it, right? So what we're going to do is, out of the in trajectory data, we are going to do a select node, so that way we can then get these two options to start off as trajectory options, and then we will select our index or make our index accordingly. So what we are going to do now is, off of option 0, we are going to promote that to a variable, and we're going to call it trajectory. What do they call it? Trajectory generate or generation data underscore idle. So we want this as our false option, because again, we're going to be doing a check like how they have it with speed 2D, except we'll be using our ground speed. So this is going to be our false option, and then we are going to promote option 1 to a variable, and we're going to call it trajectory generation data underscore moving. So essentially what we're doing for both these parts, as you can see, that when we create them as variables, we are getting a data type of pose search trajectory data that will then be fed into here. So when we actually look at the variable details over on the side, let me actually compile and save. Basically right here that you'll see, if I expand it for like the data moving, is that we have 3 different variable types in here, and then mapping curves, which you can create float curves for to do certain things with speed remappings or acceleration remappings. However, for both of the data and the moving, we will not be touching this, and also I would have to do more research on these, so that way I can give y'all better information on these. However, what we are going to do is we are going to update the rotate towards movement speed, the max controller yaw, and we are not going to touch the bend velocity towards acceleration, but I will briefly explain it. So as you can see, when we hover over the rotate towards movement speed, is that if the character is facing forward, so if we do the orient rotation to movement is true, this controls how quickly the trajectory will rotate to face acceleration, or the way we are accelerating. So you may have seen videos of motion matching talk where they would have like the trajectory component that they would use as a plugin, which is it has similar functionality in there. I don't know exactly where we're at because of the details being so small, but I saw somewhere that it utilizes similar mappings here or data here in that trajectory component. So, but continuing on from it, that it's common for this to differ from the rotation rate of the character, because animations are often authored with different rotation speed than the character. This is especially true in cases where the character rotation snaps to movement. So all this is doing is basically like properly rotating our character to properly animate or face the point of our acceleration to where we're trying to move or face when we are running forward. So for both the idle and the moving, what we want to do is we want to change both of these to 0 as accordingly into the game animation sample project. I guess in their way, what they're trying to do is we just don't need to worry about rotating towards our movement speed, I guess due to how like their animations are, but I'm not quite certain. But as we get more involved in this process, I'll have more definite information. But then the next part that we want to look at is that we have to update for both the idle and moving is the max controller yaw rate. So as you can see, the max controller yaw rate in degrees per second is used to clamp the character owner control desired yaw to generate prediction trajectory. Negative values disable the clamping behavior. So what we're basically saying in there is that, depending on our options here for idle or moving, is that we are going to be clamping the get desired controller rotation along the yaw, right? Because that, I believe, that is used in with our trajectories, like within the turn in place animations, if I understand correctly. Because when you turn in place, especially when you're idle, you get to like kind of rapidly move back and forth. So we're trying to clamp that controller rotation along that, so that way our turn in place animations work nicely. But then if we're moving, we're not necessarily turning in place, and when we are moving, we're not kind of spastically moving around our like a rotation or our mouse to like look everywhere, unless you're like kind of messing around. And also too, we're just clamping it to a different value, so that way it properly keeps our animation smooth, so that way we're not doing like weird turn and place animations with our movement. So what we'll be doing with our data moving is we're going to change this 70 to 0, because again, like I said, we want to have smooth like run animations and stuff like that. So while we're moving, we don't want to clamp the max controller yaw rate to like a higher point. We want it to stay 0, so that way when we're running wherever, that it nicely smooths our running animations depending on where we're looking. Then with idle, what we're going to be doing is clamping it to 100, because while we're idle, we want it to like turn in place nicely, very smoothly, stuff like that. So next thing we're going to do is within our essential movement data, we are going to grab the ground speed. And I realized I forgot to move that over to essential values, I guess from the last video. What am I? I am on tutorial. Okay, I just wanted to make sure. So so with our ground speed, what we are going to do is get a greater than function or node, and we're going to replace the number here with 5, or actually no, we want it to be 0. For some reason I was thinking 5 from the previous video, because I was watching that a little bit ago, or earlier today, just to make sure everything was fine. So we're going to keep it at 0, because when we start moving, obviously we are moving, so we want to end up grabbing this. So that will be our index. So if we are moving, then we get the movement trajectory generation data. And then if we're not, then we get the idle. So basically, to kind of go over this again, is that the idle and moving trajectory data variables are used to handle trajectory differently depending on whether the character is moving on idle. We're doing a ground speed check, and if false, we clamp the desired controller yaw rate to 100, and if true, we clamp the desired controller yaw rate to 0. So this helps the function distinguish between standing still and moving, and affecting how future movement is predicted. So let me go ahead and place my comment over top of it. Oop, I like how I keep missing the mark every time. All right, and then there we go, just for y'all to be able to jot down. And I'm going to move it out of the way over here. And then next, what we are going to do is now we are going to grab another property access node, because now we're going to be working within delta time. So we're going to go ahead and search for another property access node. And off here, what we want to bind it to is the get delta seconds. So what we're trying to do here is get the time since the last frame update. So we want to utilize this node to ensure that our trajectory calculations are performed smoothly and nicely over time. So let me go ahead and place my comment here because this one was a rather simple one. And actually, let me move this out of the way. All right, and then we're going to plug that into the end delta time. And let me move these out of the way for the moment just so I can move these up and ensure they're nice. And then now we're going to get our in-out trajectory and the in-out desired controller yaw last update. So from here, what we're going to do is actually promote this like input to a variable, and we're going to just call it trajectory like how they call it. Because now what we're trying to do is do a query trajectory for our post search databases. So what this is trying to do is we want to update our trajectory, which stores the calculated movement path based on past and predicted future positions. So it may not make sense right now when I say it like that, but you'll see what happens when we get into the next part when we have to start handling trajectory world collisions. So for the moment, I am going to move this out of the way, put my comment box on it for y'all to copy down. And then I'm going to move that over here. Prettify this up for me real quick. Oop. All right. So now with our last part for variable stuff is the in-out desired controller last update. So here we also want to do the same thing as we want to promote it to a variable for our input, and we want to call it previous, if I can spell, previous desired controller yaw, and they got rid of the last update. However, it's because we're trying to do an update since like the last previous desired controller yaw. Basically what this is doing, kind of like how I poorly explained it, is that we store the last frame's controller yaw, which is going to be used to influence future trajectory generation. So let me go ahead and put my comment on there. And then now we have essentially all the proper variables that we'll need for the generate trajectory post search. So now what we are going to do is we're going to modify these values inside here. So starting with the in history sampling, so we're going to set this one to -1.0, just like how they have it. So basically, let me get through the others before I actually start explaining this. So for the in trajectory history count, we're going to set that to 30. And then the prediction sampling, we're going to set to 0.1. And then the in trajectory prediction count, we're going to set to 15. So essentially what this is doing is, we're setting the sampling interval to -1.0, which likely means it's going to be like automatically set or have, do fast or automatic settings of sampling intervals or data, which means like we generate like history counts and stuff like that, like instantly or automatically. There's not like time, it's just there. It's kind of hard to explain. It's almost like when you do like binary from like 0 to 255, but then when you add an addition, it's kind of like an overflow where it goes back, where now we have like, or no, I'm sorry, with like 0, when you go back, then it kind of, when you subtract 1, it goes backward to like 255 for like the max. Basically, it's happening like automatically or instantly, kind of. I know that's kind of like a bad example, but I'm trying to figure out how best to explain this part. Just know that it's kind of like automatically setting like the next set of the history count. So with the in trajectory history count, what we're doing here with 30, meaning it's going to keep track of the last 30 frames of movement data that will be used for generating future predictions. Then when we go into the in prediction sampling interval, we set that to 0.1 so that a new prediction happens every 0.1 second rather than immediately or automatically. So with that, we'll then store 15 predicted future points, helping the system anticipate the character movement over time. So in better examples, what we're doing is automatically setting or instantly getting, the previous 30, history counts, setting it immediately or overflowing it immediately. And then within the next, 0.1 second or every 0.1 second, we are using the next 15 prediction counts to better predict our character's movement over time. So hopefully that was a bit of a better explanation. So overall, with this specific section, what this part of the function is doing is that it's responsible for updating the character's past movement history and predicting future movement based on character state, whether we're idle, moving, or moving along the ground, whatever. And it uses this data to help the animation system match the character's predicted path with appropriate animations, ensuring smoother and more accurate movement transitions. So, kind of to clarify the developer node is that if you're using custom character movement, like not the non-default movement components or like a root motion from montages, is that you may need to customize this node a little bit in order to, account for those custom setups. So now that we have gone over that, let me go ahead and prettify this real quick, and I need to add my other comment to it. So I'm going to move this up and out of the way ever so briefly, and then back up, and let me grab my note for this. So like I said, it's going to be pretty much thick, but luckily I was able to slim it down on this one, and the other one it actually looks pretty thick. So there we go. So we got that, and that way y'all can pause this for a moment and take a look at the notes here. And actually, I also forgot the post-search data note. So let me actually put that in there, because I was like, why is this so small? So let me move this up. Put that in here. There we go. Move that back down. All right, and then there we go. So as you can basically see in here. And then that is pretty much it for this section. So now with the next part that we are going to get into is doing the handling of the trajectory world collisions. So in order to get that, we want to right click in here and do handle trajectory world collisions. So you may notice something pretty similar about this, although it's within the animation blueprint. You'll notice kind of how it's similar to either a capsule trace or a line trace because of how we want to get certain collisions. We have a trace channel, trace complex, actors to ignore, debug types, stuff like that. So in the trajectory, we are actually doing a kind of like capsule trace or a line trace for our animations, because what we're trying to do with this part of the function is that we want to check if the predicted trajectory will collide with anything in the environment, such as floors or obstacles, and adjust the trajectory accordingly. So we're going to apply some corrections in here and then also get some set nodes out of here for the last part that we'll be doing. So off the anim instance, luckily because we're calling it through here, it should feed in through the execution pin out to here. So what we're going to do with this anim instance is actually refer to self in this instance. And let me connect the execution pin real quick. And then what we're going to do is all the results that we get from our post search generate trajectory, we're going to then put in the trajectory for the trajectory world collisions. So it'll like I said, it's basically going to check for collisions based off the next 15 prediction movements, or the 15 counts of our movement ahead of us. So with what we're going to be setting in here is because we're going to set this first and then I'll go over basically what everything is doing. So within the floor collisions offset, we're going to set this to 0.01. And then we're going to keep the visibility trace because in case you ever do a draw debug to kind of get the collision line and everything like that, you can always change this. But in this instance, we don't want that because again, we're trying to keep a 1-to-1 to GASP. So we're going to leave trace complex false. We're not going to ignore any actors. Again, we're going to have a debug type of none. We will ignore self. And our max obstacle height, we're going to change to 150 and then leave the rest as is. So as you can see, we modified the floor collisions offset and the max obstacle height. So to kind of go over everything that's going on in here, according to my notes, is that, so basically, again, we're taking the generated trajectory data and passing it into our world collisions handler where collisions and gravity. Oh yeah, one thing I did forget is we do need to apply gravity because we are checking for gravity effects being applied to our predicted movement. So with that, the gravity is applied to the trajectory, making the prediction more realistic by accounting for character falling or moving downward over time. Then with the floor collisions offset being set to 0.01, this sets a small offset from the floor to prevent the trajectory from intersecting with the ground too closely, which might cause glitches or incorrect positioning, like at higher numbers. Then for our obstacle height, the reason we're saying that's 150, the maximum height of an obstacle that will be considered for collision is set to 150 units, meaning anything taller than this won't be checked. So this also helps us kind of with the montages and stuff playing with the level block traversables. So this also kind of being used to account for those as well. And then because we didn't change everything else, if y'all are familiar with line tracing and capsule tracing, basically we have like our trace color and hit color for if we hit anything, and then our draw time for how long the draw debug type stays, if we're using the duration. And then this is just an array of actors we would want to ignore if we're trying to do custom events or something like that. So it's pretty much like similar to a line trace, besides like the collisions offset and other stuff. So with that, what we are now going to do is off the collision result, we are going to promote this to a variable and we're going to call it trajectory collision, because we're basically any result that we get out of it, we want to set into here. So trajectory collision, just like that. And then what we want to do after that is we want to grab our trajectory node and set it after that, because now this is where we'll be updating the results. So kind of what I mentioned in the previous video with the updated essential values with how the velocity last frame stuff was working is once it goes through this and it loops back around, that trajectory information will then be handled in here and get passed into here, so that way it takes these updates into account, sets through here, and then gets proper updates. So that is essentially what is going on here. So now I'm going to copy my Big Chungus comment node real quick, and then let me move that for y'all. And it is a lot of notes that I have, so if you do want these notes, like I said, just pause the video, and then didn't realize how off that was, and then just take your time and reviewing them or jotting them down, stuff like that. Because these are notes that I put together and researched and kind of spruced up nicely. So now that we got all that, the last part of this function is now we are going to be calculating future velocity. So I'm pretty sure y'all have looked around within the game animation sample project and have found a few functions and other stuff being used that do utilize future velocity, and this is where it's now being set. So in order for us to get that set, what we do need to do is we got to grab two nodes first. We got to grab a get trajectory, if I can spell right, trajectory sample at time, and this is from the pose search plugin. And we want to make a copy of it, because what we're trying to do now is account for 2 different points in time or predictions. So let me go ahead and set this up first before I start talking about it. So I'm going to split the structure pins for this sample because we're going to need the vector positioning out of it to set our future velocity. So at a time of 0.5, we are going to grab trajectory data and throw it in here, and then at a time of 0.4, also grab the trajectory and place it in there. We are not extrapolating any data from it, so we don't need those checked. But then what we will be doing is feeding the sample position into a subtraction node, and then, subtracting the 0.5 sample at the 0.4 sample. Then after that, we will then be multiplying that result by a float, if I can reposition this, by a float of 10. And then we are going to set or promote to variable the future velocity. So let me go ahead and hook this in here and make some maneuvers real quick, or at least some cleanup. So basically what this is doing now, so to kind of go over it, so with this first sample node is that we're trying to get the trajectory sample at time of 0.05. So this retrieves a position from the character's predicted trajectory at 0.5 seconds into the future. So this is, we are essentially, with both of these functions, is that we are looking ahead in time to predict where the character will be. So we're trying to predict 0.5 seconds into the future here, and then here we're trying to predict 0.4 seconds into the future. So by using these 2 points that are close together, the system can calculate how the character's position changes over time. So with the subtraction node, this gives us the difference in position between the 2 future movements. So this will represent the movement or velocity of the character over the brief time interval, or when we subtract this at the 0.1 interval. So then we're going to multiply it by a float of 10. So this is what I kind of gathered from doing this, is that it's likely to convert it to a more useful or standardized velocity value. So, such as converting it from a local scale to a world scale, or adjusting units to match frame rates or physics units. So that's pretty much kind of like what I got from why we're multiplying it by 10 here. So then lastly, with the future velocity, how we're setting it is that then we get the final computed value that is stored as the future velocity, and this value represents how fast the character is expected to move in the near future and in which direction. So the future velocity is crucial in understanding whether the character is accelerating, decelerating, turning, stopping, etc. So this entire part of the last part of the function calculates how fast the character will be moving in the near future by checking its predicted positions at 2 different points in time, at the 0.4 second interval and the 0.5 second interval into the future. And so by comparing these positions, it computes the character's future velocity, and which then the animation system can use to decide how to transition between animations. So for example, if the character is slowing down, it might trigger a stopping animation, or say that the character is speeding up, it can use the running animation or the start animation, right? So you will have probably noticed that in some of the functions within GASP where this future velocity is being used, and that is being calculated by getting our trajectory data using this post-search GenerateTrajectory. We're getting the previous 30 frames to then predict the next 15 every 1 second, and then we're passing it into the trajectory world collisions to make sure that 15 frames into the future, or each frame into the future at 0.1 second, that we're not colliding with anything or doing something specific. And then if so, we will handle the trajectory collision events here, or the results here, which I haven't seen where this is called, but I may have seen it elsewhere, so don't quote. I think it was more like within the AnimGraph stuff, but I'll have to double check. So then after that, we're going to get the trajectory data, that is now being updated with these future trajectory points. And then with the results from the trajectory is then we're getting future points in time, subtracting it to get 0.1 seconds into the future, or our position in the future, and then amplifying it by 10 in order to get the future velocity in the future. So like I said, that's useful for doing our stops or our starts, or checking to see like if we are going to be like moving or going to be like becoming idle, stuff like that. So that is pretty much the rundown for the GenerateTrajectory node. I'm hoping that I explained this part well enough for you guys. So, I know it can definitely be confusing with this part, because it had confused me for a long time until I started doing the research on this kind of stuff. But, now that we're going through the event graph stuff, I'm hoping that a lot of the functions that you have seen within the Game Animation Sample project are starting to make sense, especially for stuff like is pivoting, is moving, is turning in place, like stuff like that, because those are functions that we will be creating in the future as far as the series that will utilize some of these points. So now that we have gotten that cleaned up, what I'm going to do real quick is I'm going to move these all into a trajectory category, just to know what we have messed around with in here. To kind of keep it, like I said, the 1-to-1 for our GASP from scratch. And then I need to also move the ground speed into here, and I need to also, because I don't think I did it within the last one, is delete our should move. No, I did do that. So then I can go ahead and delete this, or I'm not going to delete it just yet. So that is pretty much it for this video, guys. So now that we've gotten that, let's go ahead and add our GenerateTrajectory into here. So unfortunately with these current videos for the event graph stuff is there's not really much to show you at the moment with how stuff is being used. I can only explain it as best I can, because when we actually go out and play into it, we can certainly do like the print result functions, but even those, without some of the research that I've done, still slightly confuse me even with the print console results. So however, because of how I played around with GASP, the GenerateTrajectory function does make sense to me to a certain degree, but as we go through it and as I decipher more stuff, it will start to come together. So I know it was pretty complex in this one. I do plan in the future to make your first 60 minutes of motion matching tutorial series where I go over the basics of it, since the animation blueprint for GASP is a more complex version of that. So other than that, guys, it was fun and entertaining with this video. I'm hoping that was educational for y'all, and if y'all did like that, please check out my other videos and the future ones to come. But other than that, guys, y'all have a great rest of your day, and take care.